Hello everyone, we are solving problems on the reciprocity theorem. In that, first question is, use the data in figure A and find the current in figure B. These are the given figures. This is figure A and this is figure B. According to reciprocity theorem, in any network, the response to excitation is constant, but the network should contain only single source. But here we have two sources. Whenever we have two sources, we need to apply superposition theorem. Okay, if you apply superposition theorem, what we are getting, only one source must be acting alone. If 10 volt source acting alone, this 10 volt source must be short circuit because we are replacing the internal resistance of ideal voltage source. Then this circuit becomes like this. Due to one source acting alone, I is written as I1. Now coming to this circuit, by homogeneity principle. What is homogeneity principle? In previous lectures I have already discussed. If excitation is multiplied by some constant k, then all responses in the network is multiplied with same constant k. For suppose if I multiply this excitation 5 volt source with 2, so into 2, so into 2 means this becomes 10 volts, this becomes 8 amps, this becomes 4 amps. Then circuit becomes like this. If you observe this circuit and this circuit are look like same. Now what is I1? I1 is equal to 8 amps. This I1 is due to only 10 volts. Now consider this 10 volt source. Then this current, this voltage source is short circuit. Then circuit becomes like this. This 10 volt source is short circuited. Due to this source, current is I2. Now according to reciprocity theorem, interchange the excitation and response. Then circuit becomes like this. Here what is the current? 4 amps. But here these two circuits are look like same, but here current is entering to the network. Here current is leaving the network. So what is I2? I2 is equal to minus 4 amps. Now by superposition theorem, what is I? I is equal to I1 plus I2. I1 is 8, I2 is minus 4. So what is I? I is equal to 4 amps. You may get doubt here, where is the 18 amps? If you observe in the previous circuits, the circuit, here the response is 4 amps. It is entering to the network here. This is 4 amps. But here, what is the current? Current is leaving because if we change the source from input to output, here the response is changes. The input response is changes. Here also, this current may be any other value. Okay, that current is, here it is 4 amps. But in both the cases, response to excitation must be constant. Here response to excitation is 4 by 10, that is 0.4. Here also response to excitation is 4 by 10. This is response, this is response, this is excitation, this is excitation. So that it is 4 amps. Next question is, use the data in figure A, find the current I in figure B. Here also we have two sources, so apply superposition theorem. In that first case, short the 10 volt source, then find current I. Circuit becomes like this. These two circuits are look like same as these circuits. So what is current I1? I1 is equal to 1 amp. Now 10 volt source acting alone, then short the terminals 5 volts. From this circuit, now interchange the response and input. What we getting? If we interchange the response and excitation, then you will get this circuit. Here, what is the response to excitation? 1 by 5. Here, this is response, this is excitation. So it is 1 by 5. Now, by homogeneity principle, multiply the circuit with minus 2. Then responses becomes, response and excitation becomes, this is minus 2 amps. Minus 2 amps means, minus means direction will changes. Then direction is like this. This is plus. And here it is minus 10 volts because we are multiplying with minus 2. So it is minus 2 means direction is reversed. So it is disappear. So it is 2 amps. Now it is minus 10 volts. Minus 10 volts means this is minus, this is plus. So it is 10 volts. I am drawing the circuit again like this. See here, this is 1 amp. So if you multiply with minus 2, it is minus 2 amps. Minus 2 amps means direction is reverse. So I take like this. Next, here it is plus 5 volts. So it is plus, it is minus. If you multiply with minus 2, this is minus 10 volts. So to change the direction, so remove here minus and it is minus, this is plus. So it is minus, it is plus. So it is 10 volts. Now if you observe this, current is enter here. It is plus, it is minus. So current is enter here, it is plus, it is minus. Now voltage across this 2 ohm resistor is V is equal to IR. So 2 into 2 is equal to 4 volts. So this is 4 volts. These two resistors are connected in parallel because these nodes are at same potential, because this is drag from here. That's it. These two resistors are connected in parallel. Now the voltage across resistors are same. So this is 4 volts. Here also this is 4 volts. Now current flowing through this 2 ohm resistor is V by R, 4 by 2. So 2 amps. Here this is 2 amps. Here this is 2 amps because the entire branch current is same. In series the entire branch current is same. So by KCL, what is current flowing through this? This is 2 plus 2, 4 amps. So let it be current I2. Now what is current I2? 4 amps. Next question is, use the data in figure A and find the current in figure B. These are the figures. Here he is asking current I. Here also there are two sources. So to find current I, apply superposition theorem. So one source acting alone. If 30 volt source acting alone, 10 volt source must be short circuit. Then circuit becomes like this. If you observe these two circuits almost same, but the value is not same. So to get 30 volts and reverse direction, what is the multiplying constant? Here if you multiply with minus 6, then you will get same circuit. Now if you multiply this circuit with minus 6, all responses and excitation becomes like this. Here if you multiply with minus 6, that is minus 30 volts. Interchange the terminals of or polarities of voltage source. Then this is polarities are interchanged. Here minus 24 means direction is reversed. Here minus 12, so direction is reversed. If you observe these two circuits, it is minus 30, it is minus 30, but current directions are reversed. So what is I1? It is linear passive bilateral. What is I1? 24 amperes, minus 24 amperes, because directions are not same. These two directions are in opposite. Next, 10 volt source acting alone, then circuit becomes like this. From this circuit, to get 10 volts, multiply with 2. Then circuit becomes like this. By homogeneity principle, the circuit becomes like this. If you multiply with 2, it is 10, it is 8, it is 4. Now, here what is the response to excitation? 4 by 10, that equal to 0.4. Now, interchange the response and excitation, circuit becomes like this. Here, what is the response to excitation? Again, this is response, this is excitation. 4 by 10, it is 0.4. So both same. Now, if you compare these two circuits, these two are almost equal, but only the current directions are reversed. This is I2 entering into the network. Here 4 amp is leaving from the network. So what is I2 now? I2 is equal to minus 4 amps. By superposition theorem, I is equal to I1 plus I2 minus 28 amperes. With this, I conclude reciprocity theorem. In the next video, I will start maximum power transfer theorem. Thank you for watching.